Okay, so today we're looking at 424 ratios and other situations. Our ratio is only used to compare shapes that have been enlarged or reduced. In this lesson, you're going to expand your use of ratios to new situations. What's being compared is a question that will be useful to keep in mind as you work with your team on this lesson. Katura is making berry drink from a bag of powdered mix. The directions say use 5 scoops of powder for every 8 cups of water. Her pitcher holds 12 cups of water. What's the ratio of powder to water in the directions? So the powder is 5 scoops to 8 cups of water, right? There's the original ratio. Work with your team to figure out how much powder Katura needs to mix with 12 cups of water. Try to find more than one way to describe how you would know that answer makes sense. Be prepared to explain your ideas. All right, so I would use just a kind of a nice double number line. We need to get to 12 cups, right? So scoops to cups of water. I always start with that 0, 0, and we found out that we can have 5 scoops for 8 cups. And if I doubled that, I would have 10 scoops for 16 cups. Well, I need 12 cups, right? So I've already skipped basically 12 cups of water. So we could do what we've done before. We could place that 12 in here. How do we get that, right? Well, this is that B-level stuff we used to do earlier in the year. We can cut this in half, right? 4 and then half of 5 is 2.5. So then I go, as I'm looking at it, I go 0, 4, 8, 12. So then I could go 0, 2.5, 5, and 7.5, right? All right, so I would need 7.5 scoops. All right, there's other ways to go about that. That was one method to do that. What's the ratio of powder to water in Katura's pitcher? Well, we just put that together right there. 7.5 scoops to 12 cups. How does it compare to that? Well, it doesn't look like it sometimes, but it is the same. If it's not the same, we get water or the juice doesn't taste as good, or it tastes really strong. 4-76 on the trail again. Miss Hartley's students were working with their mix of raisins and peanuts. The class found that 30% of the mix was raisins. Sophie was working with a sample from the mix and counted 42 peanuts in it. Sophie had just poured her sample back in the jar when she realized that she had counted the wrong thing. Her teacher wanted to know how many raisins were in the sample, not peanuts. Work with your team. Use the question below to help Sophie figure out a reasonable estimate of how many raisins were in the sample. Sophie knows that 30% is the same as 30 over 100. Can this be thought of a ratio? Which two quantities are being compared in this case? So if it's 30% raisins, right, that would mean that we have, this is raisins to total, right? 30%, right? That's 30 per 100. That's our total. Can you write this equivalent ratio representing the same comparison? Right? Another equivalent ratio representing the same comparison. Oh, we could do total to raisins, couldn't we? Oh, I'm sorry. I want an equivalent ratio. My bad. An equivalent ratio, another way to do it could be, say, 3 over 10, right? We can reduce that. And it's doing that same comparison. Help Sophie write a ratio comparing the number of raisins to peanuts. So raisins, if we wanted to stay with the 30%, that must mean that 70% is peanuts. So comparing the number of raisins to peanuts, we could do 30 to 70, couldn't we? Which is also 3 to 7. How could you figure this ratio without having to count them? Oh, did it. All right. Find an equivalent ratio that helps Sophie figure out how many raisins should have been in her sample that contained 42 peanuts. What I'll do is I'm actually going to use that ratio right here, and we'll do raisins to peanuts. And the raisins were 3 for 7, and we found out we just need to get up to that 42, don't we? Now, I haven't been revisiting this for quite some time, but if we remember, we can always just do multiplication to move up and down a lot faster. Should have been 18 raisins in there, right? Nikki is setting up a carnival machine with 3 teddy bears, 7 stuffed frogs, 3 rubber duckies, and 2 stuffed dinosaurs. Find the following ratios for Nikki's machine. Teddy bears to total prizes. We should find out what those total prizes are right now. 3 plus 7 plus 3 plus 2, right? 3 plus 7, that's 15 total. Number of teddy bears to total, so that's 3 to 15. We should reduce it when possible. That's going to be 1 to 5. The number of teddy bears to the number of stuffed dinosaurs. Teddy bears are 3, stuffed dinosaurs are 2. That's reduced. The number of teddy bears are 3, to the number of other prizes. Other prizes would be everything else. So 7 plus the rubber duckies, that's 10, plus the dinosaurs to 12, right? And we can reduce this one, divide them both by 3, and get 1 to 4. In the carnival game, 1 prize is chosen at random. Nikki's teacher told that the probability of randomly picking a teddy bear was 20%. Which of the ratios in part A do you think her teacher used to find that probability? Well, if we're doing teddy bears, right? If we're doing those teddy bears, but it's 20%, that usually would indicate that that's going to be 20% of the total. So the only one that uses the total would be I. So that ratio of 3 to 15 or 1 to 5. All right, Nikki is setting up a different machine that holds 60 total prizes. The machine will have the same ratios for each kind of prize in her first machine. How many teddy bears will be in that machine? Oh, well, let's use this ratio of 1 to 5. So that's teddy bears to total, right? 0 over 0. And let's use that to our advantage. 1 to 5. And, whoops, I'm not even going to go up there because remember we need 60 total, and I'm not going to take the long way. 5, what do I multiply by? 12. So I need to do that same here. It's like multiplying by those giant ones. And I have 12 teddy bears. There we go. All right, at this point you could pause. Or you could just listen to this as additional challenge here to just be prepared for a possible A-level type question like this. A box is filled with green marbles, red marbles, and blue marbles. The ratio of red marbles to green marbles is 3 to 1. The ratio of green to all the other marbles in the box is 2 to 11. Write each of the following ratios. The ratio of red marbles to the total number of marbles. Okay. All right, so red to green is 3 to 1, and green to total is 2 to 11. All right, so the ratio of red to the total. So I can't say it is 3 to 11 because red to green is 3 to 1, but green to total is 2 to 11. And why can't I just do 3 to that? Because notice these aren't the same, right? So if I increase this to be 6 to 2, notice now the green are both 2 and 2. And now I can compare red to total. So that's 6 to 11. The ratio of blue marbles to the total number of marbles. If we want to still think that our marbles are 11 as our total, and we have 2 green, let me find that. Whoops. 2 green. Come on, switch. There we go. In the red are 6, right? So that means that our blue has to be 6 plus the 2, 8. And that means that we have 3 blue marbles, don't we? So the ratio of blue to total has to be 3 to 11. The ratio of blue to green, right? Well, blue we just figured out was 3, and green was 2. And the ratio of red to blue, red is 6, And blue is 3, which would reduce to 2 to 1. Okay. All right. The big difficulty in there is making that jump right there to make that happen. Okay. Thank you. Have a good day.